Hi, this is Willy from Today 2026. This is a mega video compiled of all the parts from my first DIY CNC build. I had to change some of the music due to copyright claims, but other than that, they are the same videos. Yeah, the first video in this compilation was published early in 2017, and the last video in this mega video was published in 2023. So sit back and enjoy 3 hours of CNC building.
Today I'm going to tell you about a new project. My plan is to build a CNC machine. You can do a lot with the CNC machine, so that's why I want to build it. Here you are on my computer, and I will just show you what started this process. So I thought about this for a long time, the CNC project. So I've been looking around on the web pages to get some parts, cheap parts of course. So a couple of days ago I came over this, here it is. It was a DIY CNC machine from another person here in Moss in Norway. So I bought this DIY CNC machine not because of the machine itself, but because of the engines here, and maybe some of the spindle holder here, and some of the other parts, the motor mounts and stuff like that, and the cables. Yeah. So this is a nice starting point. I have already taken off the engines just to get them inside my apartment so I can start testing with them. When I bought this used DIY CNC machine, there was no electronics except for the engines. I also bought some other parts from the man that I bought this machine's from. I will show you the engines. Here we have one of them. It's a long stepper motor from longsmotor.com. It's 1.8 degree per step engine, 2.5 amperes, and this will be more than enough to drive the small CNC machine I'm planning to build. An office desktop CNC machine of sorts. First I just have to hook everything up and make everything run on the computer, just as a proof of concept. So that's my plan at first. We have one stepper motor. Here's the other. It's the same brand. Okay, here you can see the motor mounts. I haven't taken this off yet. So here we have 2 stepper motors, and the third one came off another project the man I bought this from had. So this engine looks like it's no typical brand. It's a generic stepper motor, probably from China. So yeah. So here we have the 3 stepper motors. They are for the X, Y and Z axis. I don't know if this is the configuration for the engines, but I can see this engine is a little bit smaller than the other 2, so I will have to figure out where to use the engines. But I think this is going on the Z-axis, moving the spindle up and down. As you know, I'm new to this. I'm new to almost everything I do. I figure it out while I go, and I watch YouTube videos and I educate myself. So what I need to control these stepper motors is something called a CNC shield, at least for the Arduino. So I have already gone on eBay and bought this CNC shield with an Arduino Uno R3 and a USB cable, of course. Here you have the Arduino Uno and the CNC shield and the engine stepper motor controllers there. This is built for 4 axes, but I'm only going to use 3 of them, and one of them I can use for something else, maybe the spindle, start and stop, or something like that. At least that's the plan. So I already bought this, it's in the mail, probably taking a couple of weeks before I get this. So the plan with this series is for me to film when I'm hooking these things up and figuring out the Arduino and the CNC shield, what kind of software I want to use, and how I'll set up the configurations. I have to get this sorted before I can even think about building a CNC machine. As I mentioned, I also bought some other parts from this guy who had this DIY CNC machine. I also bought the spindle. This is a cheap spindle from China, but it's okay for a small CNC machine. I think this is a 12-volt spindle, and with it came different sizes and stuff on the... I don't know what you call this, but 3 different sizes came with the spindle. I also got this power outlet, both stepper motors and the spindle, and the on-off switch with the spindle speed regulator here. The man I bought this from had built this box on the CNC machine I bought. This box is carved by that CNC machine, so that's quite cool. Here I have the motor speed controller for the spindle and the voltage regulator for the stepper motors. This is quite nice. I got all this quite cheap from the guy, and I'm thankful and grateful. So if you're watching this, thank you. Thank you very much. So yeah, that was it for the intro of this CNC machine series. So if you're thinking about building a CNC or just want to learn about controlling the stepper motors and stuff like that, just keep watching, and I will post videos along as I learn about this, and yeah, and you will see the progress together with me. If you like, please subscribe, and you will get more videos like this. Maybe not this amateurish, but this is what I made right now. So I hope you enjoy. I'll see you later.
Yeah, hi peeps, and welcome to yet another edition of Willy's Garage. Today I'm going to show you my design on the CNC machine I'm going to build. I started here in Sketchup. It's a free program, so anybody can download it. I can put a download link in the description. I first started the design here and imported some elements from the warehouse, 3D warehouse in SketchUp. This I got for free. It's the rails and the linear bearings and the motors with the motor mounts. So, as you can see here, I start my build simple. I'm going to use wood. I'm going to use wood on the bottom and wood on the sides. So all the squares you see here is supposed to be wood. Yeah, and I wanted a compact design. This is a small machine. It's only 60 centimeters times 60 centimeters. Maybe a little bit over that, but that I will find out when I build the machine. All the rails and the lead screws are 60 centimeters long. I used the NEMA 17 engines. As you can see here, I imported the NEMA 17 preset object into SketchUp. So I'm placing them approximately where I want them to be on the machine. But as I said before, this is only a proof of concept for the machine. So no exact millimeter measurements, but the measurements are approximately measurements. And the concept of the machine is the same as I'm trying to draw here in SketchUp. So, as you can see here, I started with the Z-axis. That's the axis that goes up and down with the spindle. Yeah, and all the measurements, as I told you before, are approximately measurements. No exact measurements here. Here, that's the plate for the spindle. I imported a spindle, but it was too big, so I imported a spindle that's like the one I'm going to use. It's a cheap one from eBay. Oh yeah. Right at this point, I started thinking about the center of gravity. So I want the center of gravity, or the weight center, to be on the middle of these beams of wood. That's because I want minimal sideways weight. Can I say it like that? Yeah, on the linear bearings on the rails, on the main rails. So I copied the machine, and I thought about bringing the whole y-axis, or the whole beam, back a little bit, so the center of gravity is moved more in the center of the wood blocks on the rails. That was it. I hope you enjoyed this preview of the machine I'm going to build. I used approximately 3 hours on this design. So peeps, please comment, like, dislike, do whatever you want, but please comment me on questions and or comments on the design of the machine. Thank you. Peeps, let's figure out the electronics. Here I am assembling the Arduino and the CNC shield. Here you have the CNC shield. It goes on top of the Arduino. These are the stepper motor drivers. Of course, I leave links to all these products in the description of this video. Just make sure to put these stepper motor drivers the right way inside. You have to look at the letters and they have to be the right way up or down. When that's done, I have some cables here. The plugs are bought on the net, links in the description. I'm cutting the cables so I can hook my stepper motors to the cables. That's it, everything is hooked up. This is the power supply I got with the machine when I bought it. It was a guy in Norway selling his old machine. Here we have the power supply for the stepper motors and the power supply for the spindle. I found a wire I can put in the Norwegian outlets and I hooked it up. The fan was going and everything was okay. I checked the power for the spindle and it regulated all the way up to 60 volts and down again. Then I checked the power on the cables for the stepper motors. It was 14 volts and that is okay. I will put them in the input on the Arduino CNC shield, 12 to 36 volts. Now I hooked up the spindle to test it out. And it went okay. I sped it all the way up. Next, I hooked up all the stepper motors. I marked them where I wanted them, X, Y and Z axis. I found the pairs for the engines first. And I figure out online where to hook up the pairs. Some of the motors I had to change the polarity of the wires to get them running. So all I can say is find the pair of your engines and then hook them up. Now let's see what I had to do on the software side. I had to go on to the Arduino website. Links in the description. Here I downloaded the Arduino IDE software. I just downloaded it. You can donate if you want. You have to download this if you want to put a program or anything on the Arduino itself. Then I went to the GRBL website, links in the description, github.com, and downloaded the GRBL code for the Arduino. After you've done that, you get this zip file and you extract it to wherever you want. Inside the folder you have another folder called GRBL Master. You go inside here. Inside this folder you have a folder called GRBL, and you copy this folder or cut it out to the destination of your installation of the Arduino program. And inside the libraries in the Arduino program, you paste it. When it's in there, you can start the Arduino program one more time. Inside the Arduino program, you have to check first if your Arduino is connected. You check this here. I have the Arduino Genuino Uno and the COM port. Then you go to the libraries and find the GRBL folder, and you go on the upload. Close the old window, maximize the new one, and you have to compile it and verify its correctness, I'm supposed. It's just a warning about low memory. When it's verified, you can upload it to your Arduino. You get the warning with low memory, but that's okay. The next thing you have to do is to go on the GitHub and download the universal G-code sender. I have the links in the description, and you download the zip file. You extract the zip file to wherever you want, and you get this file start bat. But before you do this, you have to remember you have to go to the java.com website and download Java. Unfortunately for many, but that's what you have to do. Okay, go to the start bat file. And here you have the universal G-code sender. Be sure to have the right COM selected, have the maximum speed, and you open. When you do that, you see your Arduino is connected. And here, as you can see on my engines, I have a connection, and you can turn them or steer them by pressing the buttons. So, all is well here, all is good. I was very happy when this worked. And the next thing, I wanted to start a program. I do this by using chili pepper. It's a web-based G-code sender. I go to the GRBL workspace. When you go in here, you figure out that you're not connected, and you have to download a serial port server. It's down here. It's down here. And you download the one for your operating system. Once that's done, you have to be sure to close the universal G-code sender. This is important. And you get the zip file and you extract it, and you get to start the server by one file. When you've done that, you refresh the window in the chilipepper.com window. Here you see that it has connected to your Arduino, and you press it and everything is okay. So I think it's just to start the program, and And here you see all the stepper motors going according to the program. I had a fault on one of my stepper motor drivers, as you can see. I have ordered new ones. It wouldn't drive my engine. I tried to clone the x-axis to get the two engines on the x-axis. I also had a problem with my y-axis engine. This was quite weird because it was a new engine. So here's the problem. When I accelerate the speed, it just stops. I don't know why. So if any of you know why this y-axis engine is stopping like this, please let me know. You can see in this video the stepper motors are too small. The motors are stalling and the computer don't know where the axes are in real life. So this makes the cutting quite impossible. So the first problem I have to address is all the stepper motors. These are NEMA 17s. I used NEMA 17s on all the axes. The first thing I have to do then is to change all the stepper motors to the NEMA 23. The size difference is quite big, but what's good is that when I made the CNC machine, I took in count changing the stepper motors. So all the stepper motors, it's possible to change to bigger motors, as you can see. I have not locked the design to one stepper motor size. That's the first problem I have to address. The second problem is a follow problem when I change the stepper motors. My CNC shield might be too small for the motors. I know the motor here, the highest current is 2.8 amperes. And I don't know if the CNC shield is big enough to support that high current. So I have ordered some other stepper motor controllers called TB6560 that are manufactured for 3 amperes current. I will leave a link in the description. I'm going to control those controllers with the Arduino and or the CNC shield. I'm not sure. I have to look at that when I get that far. Okay, then the third problem I have to address is the y-axis. I have only used these rails. They are non-supported rails. The problem with these rails are that they are bending. No force at all and they are bending. This makes the machine very uncalibrated. So I have to change those rails with some 600mm supported rails. I bought this on Banggood. I will leave a link in the description. So I'm going to use these rails on the y-axis like this. I hope that will fix the problem with the y-axis wobbling when the router is moving in its toolpath. The fourth problem I have to address are these back plates. They are good as plates, but the problem with this wood is that it's not straight. So I have some problems when I'm tightening all the screws for the linear bearings on the rails. When I do that, I also make it not straight, so the linear bearings won't glide on the rails like they should. The same with the plate for the Z-axis. I don't know if you can see it, but the plate do have some bend in it. That is no good. My plan there is to use this material. This is called plexiglass material. It's 1.2 centimeters thick. It's sturdy as, yeah, it's very hard and straight. I think I'll use that material for both the y-axis plate and the z-axis plate. C-axis, z-axis. I don't know, call it what you want. And then I come to the fifth problem I have to address. Here we have the lead screw for the x-axis. These are the x-axis supported rails. That's all good. From the lead screw anti-backlash nut and up to the z-axis rails, I use this steel plate with these corners. Okay, the problem with this, you can see when I'm trying to pull the z-axis back and forth. You can see it moving quite a lot. those are the problems I have to address in my next videos. I have some tinkering to do also with the settings on the GRBL and the stepper motor controllers and the Arduino. So I hope you enjoy watching. Maybe you would like to subscribe, maybe you would like to like the video, and maybe you would like to dislike. Anyway, comment below if you have any questions about my projects. Thanks for watching. Bye. Hi again, good people. Welcome to another DIY CNC build video. As if you have watched my previous videos, you know I have some problems with my CNC shield and these stepper motor drivers. They are too small to drive my motors. I have the NEMA 23s. I have tried to regulate the current by adjusting the potentiometers on each controller. You have to be very careful when you're doing that because the potentiometers is easily damaged. But anyway, these stepper motor drivers don't work for me. I need something that is much stronger. That's why I have bought TB6560 stepper motor controllers. These have a max current of 3 amperes. My stepper motors are max 2.8 amperes, so these controllers should be more than enough. My mission on this episode is to connect the Arduino Uno, to the TB6560 stepper motor controller. The first thing I figured out is that the CNC shield that sits on top of the Arduino Uno is no longer needed. So I take off the CNC shield and push it away. Then I have the Arduino Uno, the board, and I'm going to use the different outputs on this side to control the TB6560 stepper motor controller. When I've done that, I'm going to hook up my old NEMA 17 stepper motors to the TB6560 controllers, just so I can test that everything works okay before I hook up to my CNC machine. These are the engines or the motors that I used the first time on my CNC. They were a bit too small. I found out that this maybe would have been big enough if I had used the TB6560 in the first place. I don't have the opportunity to test that out, but I can at least test to wire this TB6560 up to the Arduino Uno and driving all my 4 stepper motors, 3 axes, 2 stepper motors on the X-axis. I have also bought a new power supply. This is bought out of banggood.com. I will leave a link in the description, of course. This is the 24 volt, which is the recommended voltage for the TB6560s. And this has a max current of 15 amps. That is more than enough. That's good because I'm going to use the same power supply to power the cooling fan in my electronics cabinet and to power everything else on the CNC machine, except the spindle, of course. So with that said, I'm now going to try to explain the outputs we need on the Arduino Uno. Now, with the Arduino Uno out of the way, let's dive into the TB6560. I'm going to try to explain how all these switches function and all the inputs and outputs we need to use. So let's dive into the 6560. that shows you the functions of all the switches. Let's take a closer look at the first table. Here you have the switch 1, switch 2, switch 3 and the S1. This means the switch 1, switch 2, switch 3 and S1. And these 4 switches is used to control the running current to the stepper motors. If you turn it a little bit around, you can see here you start at 0.3 amperes. Then switch 1 is in 0, switch 2 is in 0, switch 3 is in on position, and the S1, the first switch on the multiple switch, is in 1. So if you go up, you have 0.5, 0.8, 1 amperes, 1.1, 1.2, 1.4, 1.5, 1.6, 1.9, 2, 2.2 and 2.6, and on the top you have 3 amperes. That's the maximum for the TB6560. I'm going to at first run my engine in the 2.6 configuration because my NEMA 23 engines are rated at 2.8 amperes. So when I'm going to run the 2.6 configuration, the first switch should be in the on position, second switch should be in the on position, the third and the fourth should be in the off position. So if we look at the other settings, S2, that's the second switch, you have something called stop current. This is how much current the stepper motors should get when they do not run or when they stand still. They need current to hold the position and not get out of whack. And that's a good thing when you have a CNC machine and you have zeroed everything in. You don't want the steppers to move without the PC telling it to move. And then we come to the S3 and the S4. S3 and S4. It says excitation mode. Here you have the micro steps setting. The higher the micro steps you put, the lower holding torque the engines get, or the lower starting torque. But also the higher the micro stepping you set, the higher resolution you get on the CNC. I decided I have to go for 1/8 at first. Maybe I have to push it down to half micro step. Then we see we have to put the S3 in the on position and the S4 in on position. On. The decay setting is that in fast mode you allow the current when the engine stops to go directly to the power supply. This allows the magnetic field to collapse quickly and the motor will coast afterwards when it stops. The advantage will manifest in that you can have faster motor speeds. But in the slow decay setting, you feed the current from the engine or the motor back to itself. This means the magnetic field collapses slowly. The motor will dynamically brake or stop instantly. This is desirable because it will not, then you will not lose accuracy when seen, but it will increase or limit the motor's speed. There you have all the functions of these buttons. mains. Okay, it didn't explode, but you can see the lights. All the stepper motors have a holding power, I think. Except for this one. Connect this harder. Okay, let's go to the machine control. Stepper size 10 millimeters. I'm really excited now. This should be the set axis. Oh yeah! Let's take it a little bit further. 55 centimeters, 50 millimeters. That's good. Let's do the same for the y-axis. The speeds you control in the Arduino program. I haven't done anything with those yet. And of course the steps per revolution and steps per millimeter. X-axis. I'm quite anxious about this. Maybe I should test all the axes together, so let me start up a G-code program in the Universal G-code Center. This episode is long enough. If you would like to download my wire diagram for the TB6560 controls, go to my webpage. The link to my webpage is in the description. And as always, if you have any questions to me about any of my projects or future projects, please leave a comment on this video or go to my Facebook page and leave me a private message. Also on my Facebook page I can send files as G-code files, the graphic files and everything directly to you if you want something like that. So again, I hope you found this video interesting. I hope you will continue to watch my series on the CNC and maybe go back and watch some of my other videos. And of course I hope you push the like button on this video and maybe you would like to subscribe on my channel. Please do so or not. It's up to you. Goodbye and thank you very much for watching. Have a nice day. As you can see, the X-axis mount from the lead screw to the Z-axis rails is a little bit wobbly. This is because the metal here is bending and the nut on the lead screw is allowing the metal to move by tilting a little bit back and forth, as you can see here. My plan is to fix this by mounting another plate on this side of the lead nut screw. This way I'll get 2 points and it will not bend as easily. I will also get a stronger connection up to the X-axis carriage. fixed it. The double plate up here, double angle iron up here. So let's see the difference. This is before. This is after. This is before. And this is after. Yeah, I think it's much better. Thanks for watching. Bye. Hi, good people. Here you have the machine today. I have stripped it of all the preliminary wiring, and my mission now is to wire all the engines and lay every cable I need for the machine to work properly. Like you have seen in my previous videos, I have wired up the TB6560s and they work. So I look forward to wire up my NEMA 23s to the TB6560s. I'm going to use a shielded cable like this. I don't know if you can see me. Let's focus. Yeah, I'm going to use a shielded cable for all the stepper motors and the limit switches and everything. There are 6 individual wires plus the ground wire. And of course you have the shield on the outside of all of them. I'm also going to use these cable guides or cable rails or what you want to call them. These are bought on the internet and I'll leave a link in the description. So I want one up here. I have one small for the Z axis and I have one on the side for the X axis. You can see I've gotten these ferrite rings which I'm going to put on all the stepper motors. It's just a ring and you turn the cables around, through and around and through. Those are ferrite rings and they will eliminate some of the frequency noise or the electric noise. Let's start building! My plan is to take these heat shrinkable tubing. I wrap each pair of the stepper motor. I will heat shrink those. Then I will put on the ferrite ring, have the cables go back inside, around. I will try to get them split off from each other on the ferrite. I'm not an expert at ferrites, but yeah, I think maybe it's good to have them separated. I will take off the outer isolation or insulation here, long enough to cover some of these cables. Then I will get a bigger heat shrinkable tube, and after I have soldered cables together I will heat shrink it over everything. I don't have my heat gun here, so I'm sorry, but I have to use a lighter to heat shrink the tubes. Don't do this at home.
the camera went dead, the battery. But I have finished the wiring. Here I have the wiring for the limit switch on the y-axis. It's going inside here. Here I have a cable guide for cables to the spindle or light if I want that later. And the limit switches, of course, which is going on this bracket. Everything wired up here. On all the stepper motors I only used 4 wires, and the rest I've taken out that so I can use them later for other things. Wires coming up here and into this cable guide. Here I have the cable for the limit switch y-axis. I also need a switch inside here for the y-axis, and the cable goes down here and out of the cable guide here. As you can see, it's quite a few cables. And here I have a wire for the X-axis limit switch going on here somewhere. And that cable goes all the way through this cable guide and outside down here for the limit switch on this side. And of course it just loops back inside and out for the control box. X-axis stepper motors there and there, both wired into the cable guide down out for the control box. So as you can see, I've gotten the whole machine at least cabled up, not wired up yet. But I think that will be that for this episode. If you would like to watch me finish this build and make stuff with this poor little CNC machine, just continue watching my channel. And if you have any questions at all, leave them down in the comments, or go to my Facebook page or my webpage, links in the description. I also have Twitter, but I don't use that as much. So do some of those things if you have any questions or comments, please. And if you like, please hit the like button or the dislike button. That's it for this time. Thanks for watching again. Bye.
Hi again, people. Welcome to another edition of Willis Garage. Today I'm going to talk a little bit about the GRBL configuration on the Arduino and how you can change the values and what the values means. I've gotten my information from the internet and I'm no expert at this at all, so if I get anything wrong, please let me know in the comments. For the configuration of my GRBL code, I used a link on the github.com. I will leave this link in the description so you can read it yourself. It's a very good article, and everything you need is listed up here. But anyway, let's get going. I start by starting the universal G-code sender. I open my COM port for the Arduino and I check to see if my machine is connected. And it is connected. To get your configuration file up, you type in $2 in the command line and then press enter. Then you get the list of all your settings. Let's say I want to change the $0 to another value. To change it, I just copy this up in the command line. So you type in this and the value you want to change it to. Let's say I want to change it to the value of 30. I press enter. And then the next time you type in $2, you can see that the $0 is changed to 30. So that's how we change a value. I will change it back to 10 as it was before. Like so. Here you can see again that it has changed to 10. First, I just want to go through every one of these points and tell you what they do in the GRBL code. I will list them up fast and focus on a couple of these points that we need to configure the CNC machine. The $0 is step pulse in microseconds. This controls the length of the step pulse. The $1 is the step idle delay in milliseconds. This means that every time your stepper completes a motion, the GRBL will disabling the steppers by this value in milliseconds. The $2 is the step port invert mask. This is a setting most users won't need, but it can be useful in certain CNC stepper drivers that have peculiar requirements. The next is the $3. Here you can invert every one of your axes. There is a list on the link, the github.com link in the description, where you can see what kind of axis you invert by changing the value on the $3. I put it to the value of 6. This means that I'm inverting my y-axis and my z-axis. The $4 is the step enable invert. This is for the stepper motor in enable pin. It's normal that it's high to disable and low to enable. But if you somehow need it to be the other way, you can change this value. The $5 value is the limit pin invert. This is just the function of your limit switches. I will come back to this in a later video. The $6 is the probe pin invert. This is the same but for the probe pin if you use that on your machine. I will go to the next $10 status report. This setting determines what GRBL real-time data is reported back to its user. I will leave this as it was. Then we get to the $11. There's a junction deviation in millimeters, and the same at the $12 is the arc tolerance in millimeters. These two settings are important if you want to change the way your CNC machine behaves in a junction or a bend or an arc. Next is the $13. You can enable this if you want your CNC machine to report back in inches instead of millimeters. Next, the $20 is for the soft limits. This is a feature to help your machine not to travel too far. So you can input some soft limits or virtual limits that prohibits the machine to travel. Okay, next is the $21. This is hard limits. If you are using limit switches in the end of your axis. I have not gotten this far on my CNC machine, so I will leave this as it is. The $22 is the setting for the homing cycle. This is if you have limit switches installed. The $23 is also for the homing cycle. This is the invert on the direction. The $24 is also homing cycle. It's the feed rate. The $25 is also for the homing cycle. It is the homing seek rate. The $26 is also for the homing cycle. The $27 is also for the homing cycle. It's the pull-off distance in millimeters. The $30 is for setting max spindle speed in revolutions per minute. The $31 is the minimum spindle speed in revolutions per minute. The $32 is to enable the laser mode. This is if you have a CNC machine with a laser instead of a spindle. And now we come to the important ones for your machine in the beginning. We have the $100, 101, 102. These are for the X, Y and Z axis and is the steps per millimeter. This is why you need to calculate your machine's step per millimeter and calculate from your stepper motors, which has a step per revolution. So these settings are very important for your CNC machine to travel 10 centimeters if your G-code requests 10 centimeters. The $100, 110, 111, 112 is the max rate in millimeters per minute. This is if the G-code requests max or rapid travel. This is the max feed rate. Then you have the $120, 121, 122. This is the acceleration in millimeter per second square. This is how fast your axis accelerates when it gets a request to move. These settings you can play around with. The last setting is the max travel for the X, Y and Z axis in millimeters. This is only functional if you have the soft limits feature enabled. I will now start trying to explain how I configured my machine. As you can see, I have configured my machine to 100 steps per millimeter on all the axes. I have my stepper drivers on a half turn and I have calculated that to travel 1 millimeter my stepper motors needs 100 steps. And you can check that out. Let's take up my CNC machine here. I have the spindle on the 40 millimeter mark on a ruler, and now I'm going to ask the y-axis to move 20 centimeters or 200 millimeters. And as you can see, it stopped on the 20 millimeter mark, so it has moved 20 millimeters from 40. Now I'm going to ask the y-axis to move 10 centimeters. And as you can see, it traveled 10 centimeters. Let's say that you install the Arduino and the GRBL code and your stepper drivers is out of whack. I'm going to type in a step length of 250 steps per millimeter on the y-axis. And now I'm going to ask it to move 1 centimeter or 10 millimeters. As you can see, it moved a lot further. It moved approximately 2.5 centimeters. So let's take it back. Now I'm going to ask it to move 5 centimeters. And it moved a lot further. It moved 12.5. I'm going to take it back. Yeah, as you see, these settings are very important to get your machine to run properly. If you don't have your lead screw pitch angle or your belt pulley pitch angle, you can figure out by measuring how much steps it needs per millimeter. I'm going to try to explain. You know how many steps your stepper needs per revolution. For example, my stepper motors are 400 steps per revolution, and I set the stepper drivers to a half a step. That means it has 800 steps per revolution. So if you then go into your settings and input 800 steps per millimeters, press enter. You can now send your axis 1 millimeter, and then you know the stepper motors should run 1 revolution. And then you can measure the millimeters it runs in real life. Let's just see that the stepper motor turns 1 revolution. This is the Y-axis stepper motor. Now I will send a G-code of 1 millimeter and it should turn 1 revolution. And then you can measure. Now the Y-axis should move 8 millimeters because I know my lead screws have a pitch of 8 millimeters. As you can see, that is correct. And now you can calculate your steps per millimeter because you know you are sending 800 steps to your stepper motor and it turns 1 revolution. And you know your Y-axis moves 8 millimeters. Then you can calculate this by taking 800 steps divided by 8 millimeters, and you should get something like 100 steps per millimeter. That's why I have the setting on 100 steps per millimeter. I'll input that again, 100. And now by sending 1 millimeter to the Y-axis, it should move 1 millimeter. As you can see, that is correct. Now let's try 20 centimeters. And back. And that's how we verify that you have the correct settings. And this method you can use even if you don't know your pulley belt or lead screws pitch or how much revolution it needs to move 1 millimeter. Now let's check out the other settings. We have the 110, 111 and 112. These are max rate in millimeter per minute. Let's try to change the Y-axis max rate to 3500. That's quite a lot. And let's try to move it 100 millimeters. As you saw, it moved 100 millimeters, but it moved quite a lot faster. Let's try to change this to 4500, 100 millimeters. And back. Let's try to move it 200 millimeters. Yeah, as you can see, it went quite good. I have it at 2000 because I want to make sure the steppers don't lose any steps. But of course, I might want to change these settings later so the machine can go smoother and faster. The next setting we are going to look at is the acceleration setting. This is the millimeter per second square. Let's change this to 100. And let's try to send 100 millimeters to the Y-axis. As you heard, the acceleration was a little bit faster. Now let's try to put it at 200. As you can hear, the acceleration and the stopping is affected by this setting. This is also something you can play around with. You can try to find your maximum setting where the stepper motor stalls and then retract the value about 20%, and that should be good. But for now I have mine at 50 just to make sure nothing is lost. I'm going to change these settings also later. There you have it, folks. That's how I configured my CNC machine. In the link I have in the description for github.com you have a much more detailed instruction. But I hope my video will help you to start your configuration process. And remember, these settings are not dangerous to play with. Just try a little bit, but be sure to get them right before you start carving, because if not, everything will go to shit. So, anyhow, thanks for watching, I appreciate it. If you have any questions, please let me know in the comments, or on my Facebook page, or on my webpage. On my webpage I also have some diagrams and pictures you can look at. And on my Facebook page I always put out some behind the scenes material for you to see. Thanks again for watching. Like, subscribe, dislike. See you later. and welcome to part 16 of the DIY CNC machine build here on Willie's Garage. My CNC machine is starting to work okay, and I figured out most of the settings, as you can see in some of my previous videos, but there are a few faults that I want to address. First one is that my Z-axis is guided by non-supported rails. This makes the Z-axis a little bit wobbly, and I want to replace those with some supported rails like the one I have on my Y-axis and on my X-axis. The second fault is my spindle. I have a Chinese spindle, it's about 400 to 500 watts. It's too weak, and it has a ER11 collet, which I think is too small, and the tools are too weak for my taste. So I want to change the spindle for something more powerful and something that will fit my use, or what I want to use my CNC machine for. As some of you already know from my Facebook page, link in the description if you want to check that out, I have bought a new MAKITA spindle. This is the RT0700C. It's a 230 volt, 3.1 amperes, 710 watt spindle with an RPM range of 10,000 to 30,000 revolutions per minute. So this is a much more powerful spindle, and it has a bigger collet for bigger tools. So in this video I plan to design the mounts for the MAKITA spindle, in Fusion 360, and later I plan to carve it out from acrylic material. That's at least the plan for this video. Let me start the design in Fusion 360, and then we're going to see how it all goes. Okay, what happened here was that the carved piece broke loose from the stock piece. This was not supposed to happen because of the tabs. I put the tabs in Fusion 360 in the cam environment. The tabs are designed to hold the piece firmly to the stock piece while the milling process is going on. Lesson learned. When putting the tabs on the piece in Fusion 360, make them thicker than 1 mm. Let's continue. right, the mounts are finally finished. As you saw, I had a couple of problems during the process. First off, the piece broke loose from the stock piece, and I had to abort the milling process. This resulted in some beauty blemishes, like the ones you see here, but it's no biggie. Then I had to take each mount and find a new 0 point so I could carve the 65mm hole in the middle. This was no problem, but it was a lot of hassle. I also had to carve the slot here for the fastening of the spindle manually using the universal G-code sender. 4 centimeters that way, down half a millimeter, 4 centimeters this way, down half a millimeter, 4 centimeters that way, all the way through the piece. Let's see if they fit the MAKITA spindle. Yeah. Like you see, they fit like a charm. The spindle is going to be mounted like this, with the Z-axis plates down here, if you know what I mean, like this. And as you can see on the CAD drawing down there, I have to drill holes here, here and here, and I have to drill a hole through here for the tightening of the spindle. Again, thank you for watching. If you have any questions or requests, please let me know in the comments below. Please like or dislike this video, subscribe to my channel, or go to my Facebook page or my webpage to see more. Links in the description. Bye! Hi peeps, and welcome to part 17 of the DIY CNC machine build. Today I'm just going to talk to you about some improvements I want to make on my CNC machine. As you probably already know, I mounted my CNC machine with unsupported rails the first time. I then later changed the Y-axis rails to supported rails. This was because they were way too wobbly. And now I have figured out that I also want to change my Z-axis rails for some supported rails. These are just 20 centimeters long or 200 millimeters long, but they still are too wobbly, as you can see here. One more thing is that I want to change the bracket I use from the lead screw nut on the Z-axis to the Z-axis plate. That bracket is way too small and thin, so I want to change that bracket for something more solid and thicker and better and stronger. I also miss one of the bearings on the lower part of the lead screw. This is not a big problem, but I want to put it on there so the vibrations in the lead screw gets minimalized. These improvements will improve the performance of my CNC machine. So I want to make some comparison videos from before the rebuild and from after the rebuild. One more thing is that in the last part of this DIY CNC build series, part 16, you saw me making some mounts for my new MAKITA spindle. I of course want to replace the Chinese spindle with that new MAKITA spindle. When I do this, I also have to make a new backplate for the Z-axis with all new holes and everything I need to get everything in place. And I plan to make that plate on my CNC machine as it stands today. So I'm going to use my old CNC machine to improve it and to make a better CNC machine. I like that idea when the machine makes a better machine. Yeah, I hope all these improvements will make it worthwhile and that the CNC machine will get higher performance and mill out some new nice projects for you to watch. As always, subscribe to my channel, like or dislike this video. You can go on my Facebook page and like my page to get updates and behind the scenes information. I also have a Twitter and Instagram, which I do not use that much, but you can go there if you want. I hope you have a nice day. That's it for this time on Willys Garage, Norway. Goodbye. Hi again, people. It's time. The time has come to tackle the CNC machine once again.
Ladies and gentlemen, the CNC machine.
Oh, hi DIY CNC machine. I'm glad to finally see you. I'm really sorry I haven't given you enough attention lately. Ah, that's good. So, DIY CNC machine, after all this time, what do you want me to do? Okay, so you want me to fix you? I will try to do that. But in reality, I do not need to fix the CNC machine because it already works, as you can see. I have a couple of ideas I want to do with it, and I want to change these linear rails for some supported rails. These supported rails, as you can see, the Z-axis is quite wobbly. Here I have the linear bearings for the rails. So these are going on the Z-axis like so. And I also want to change the spindle. This is a cheap 500 watt Chinese spindle, and I want to put on this new MAKITA spindle. It's the RTO700C spindle from MAKITA. I want this to go here on the new Z-axis plates. I have made some mounts for this spindle, which I'm going to use here. So first I have a lot of measuring to do to find out where everything goes, and I have to design the plates in Fusion 360, then carve them out of MDF materials on the old CNC, and then I can dismantle this CNC machine gantry and put up the new one. Oh, hold on your horses. There's nothing wrong with this video. I only paused it here because the process of me designing the gantry plates in Fusion 360 and making the toolpaths and carving it on my CNC machine took a little bit long and resulted in a ridiculously long but interesting video that you have a link for up in the corner here now or down in the description. So if you want to see how I work in Fusion 360 and how I generate toolpaths in the CAM environment and how I got the plates for my new gantry out on my old CNC machine, please go and check that video out either now or after this video. When I now press play, I will get back to the building of the new gantry after the plates for the X-axis and the Y-axis is carved. Hit play. Do you remember the MAKITA mounts I made in another video? I made the mounts out of white acrylic. I thought that would be fine. But I tried to drill holes in them. As you can see, it just snapped right off. Both. They just snapped right off. I have to make new ones. I'm making the new ones out of the 19mm MDF material that I used to make the backplates for the Y-axis and the Z-axis. And I want to have 3 mounts up on each other. So what I did was go into my computer and I opened the file which I used to carve the acrylic ones. I then copied one of the mounts, so I got 3 mounts laying next to each other, and I had to increase the height of the material to 19.6 millimeters, which is the height of my MDF material. So after I did that, I made the G-codes, and I sent the G-codes to the Universal G-code Center, and I carved 3 new mounts for the MAKITA spindle. I had 800 millimeters per minute feed rate and 1mm depth per pass. Everything went fine except that my tabs have a tendency to be too small, so they break off and the material loosens from the stock. This also went fine all the way to the last piece when the tabs loosened and the whole stock loosened and everything went sour. I can use the mounts no problem, and I will continue the assembly of the new gantry. Now that I have carved the pieces, we can start assembly. Here we have the Z-axis plate. I had to go over and drill the holes for the linear bearings because I need them to be 5.5 millimeters so I can get the M5 bolts in the holes. Let me show you something. The MDF material has a tendency to crack between the layers in the MDF. If you're working with MDF, you have to watch out for this, and me too, I learned that now. But here I want to make some pieces between the MDF here, and so this will tighten together just fine. Here we have the Y-axis plate. I have the guided rails, bolts for the guided rails, the mounted bearings, M5 bolts, M5 bolts, M4 bolts, M4 nuts. Well, the time has come. I have mounted both the Z-axis plate and the Y-axis plate. Now is a big moment. I've been waiting for this for a long time. Planning and designing and building and ordering parts. I'm going to start dismantling the old CNC gantry. Or at least the Z-axis plate and the Y-axis plate. This is a big moment, so wish me luck. Hi again, good people. The CNC machine is under eternal development. That means I'm improving the CNC machine as I go. Every day I'm thinking about new things to do with it, to get it stronger, more precise, and everything like that. Last time you saw me rebuild the gantry. This works good. I have tried a little test for a dust shoe, but this has nothing to do with the dust shoe I'm going to build. Today I'm going to tackle the stepper motor mounts. As you can see, they are quite loose. The Z-axis one I fixed in the last episode, so this is okay. But today I'm going to tackle these stepper motor mounts. I'm going to improve on the angles I have here, and I'm going to do that by welding on some steel plates on the sides. That way I will stiffen up this movement and this movement. This is something I have to do, and I'm going to do it now. Okay, as you can see here, this angle iron was something I found when I built the machine. You can see that the steel on the angle iron doesn't go further back than here. That means I can't bolt this side of the stepper motor tight to the angle iron. So I'm now thinking about improving it even more and welding on a bracket that goes on the back side here and down, so I can tighten the stepper motor on this side also, just to make the whole thing more sturdy and more precise. Don't do the same mistake I did. There are two set screws. My God. So there you have it. That was me modifying my stepper motor mounts on my CNC machine. This makes the mounts sturdier and more tight than the old ones. The old ones was very wobbly, as you can see, and the new ones is very sturdy. As you also can see from this video, I am no expert welder at all, but I think these welds are doing the job and I'm learning something every time I use it. As you saw in the video, I also painted the mounts with 2 coats of black heavy-duty paint. That's it for this time. Please check me out on Instagram, Facebook, or check out my website, links down below. And if you want to see more videos of my DIY CNC machine or other things in my workshop, please hit that subscribe button. That's it for now. Goodbye. Hi good people, and welcome to part 20 of my first DIY CNC machine series. As some of you already know, I have had a wish of making and mounting a dust shoe on my DIY CNC machine. In this video I will show you the process of designing, failing, and in the end making a dust shoe design that works quite good. I made my design in Fusion 360, and you first see me making a mock-up of my spindle so that I can design the dust shoe around it. In my first attempt I was thinking about making a plywood body and attaching it to the Z-axis plate with bolts and thereby making it adjustable in the height. This in itself, in theory, is a good idea, but in practical use it's not that easy or practical. Here you can see the plywood plate I was thinking about using first. And then I imported my vacuum hose adapter from my DIY Dust Cyclone project. And attach it to the plywood plate with bolts. My thoughts here was to 3D print the adapter on my 3D printer. As I finished up the design, I saw that the transition from the bottom plate to the adjustable blocks just wouldn't have been strong enough, and they would surely have broken off if I used them. I altered the design by moving the adjustable pieces all the way up on the Z-axis plate so I could make stronger attachment brackets out of plywood. I had to make the base plate bigger to get room for the corner brackets I was thinking about making. Corner brackets got some holes in them to reduce the weight. When I finished this design, I saw that this whole assembly was going to get big and heavy, and even if it were a bit adjustable up and down on the Z-axis plates, it would have been too big and bulky for my CNC machine. This made me scrap the whole idea of making it adjustable and out of plywood. Why not make it fit right on the spindle itself, and why not 3D print the whole dust shoe? I had to do one change to the CNC machine for this to work. I had to move one of the spindle clamps or mounts that I made in another video, so I could get room to mount the dust shoe right on the spindle itself. This made me come up with a much slimmer, lighter and usable dust shoe. So I fired up my Creality CR10 Mini 3D printer and printed the whole dust shoe. So here we have the first edition of the 3D printed dust shoe. It was quite okay, but I made the body too thin in this transition, so it broke off. For now I just glued around here just to test the design, and I will go back later, make this thicker, this body here. Just so you understand how this dust shoe is going to fit, it's going to go on the router like this, on the spindle. This is quite a good fit on the spindle. When I have attached the brushes, I also want to make a set screw, one on each side, which goes in here and attaches to the spindle. I'm going to do that after I have attached the brushes. The brushes are going to be under here, and the vacuum hose is going to hook up on this one. That way it's going to suck all the dust, hopefully, up in this hose. Oh yeah! Here I have my trusted old glue gun. It's at least old, maybe not so much trusted. Here I have the dust shoe in my vise. Now I'm going to glue on the brushes. But before I do that, I want to cut off the top layer here, just so I get the brushes even further up inside the 3D printed piece for my dust shoe. So I'm going to cut these brushes right about where the top seam is. That way the brushes will still be in here. This is a common tool that I'm going to be using, and a common length from the spindle if I'm using other tools. Like so, like so, and like so. I'm putting on the dust shoe so I can cut the brushes to length. Looking where the end of my tool is, that is where the stock piece is going to be that I'm cutting in. And I don't want the brushes to be too long, because then it will press up like this, and that's no good. I can see the tool is about maybe a little bit down. So the end of the tool is approximately where this tape is. Now I have to cut the brushes. Next thing I want to do is to make some set screws, one on each side here, so I can attach the router to the dust shoe. So I'm going to use the M6 bolts, and I'm going to thread the holes with the bolt itself. My plan now is to test the dust shoe. But first I have to attach a workpiece. I made a G-code here now with the 0 point in the middle of the piece. So let's set the 0 first. Set the 0 point, erase the set axis again. Like so. And I can attach the dust shoe. Attach the vacuum hose. It goes on this tube. I'm going to attach this permanently here later. And now let's test if this is going to work. Okay, I don't think this was too bad. There was no saw spoon spitting out in the back and on the wall and up in the air like it normally is. Everything got sucked up except some sawdust that got out in the back. But this is very good. There are some brush leftovers, but no problem. Let's clean it up.
Thanks for watching. Check out links below for my website, Instagram and Facebook. And please leave a comment, like or dislike, subscribe if you want. Goodbye for now.
Hi again, people. I'm here with a new CNC video. I have a project coming up where I need the CNC machine to be somewhat aligned and perfect. Therefore, I'm going to make two videos now, where one video I'm going to align the router itself to get it aligned in a straight angle to the spoil board. After I've done that, I want to make a video where I make a new spoil board for the CNC machine. I have had some cuts in the past where I found out that the router was not flush with the piece I was cutting in, as you can see on these pictures from the cuts. The way I'm going to do this now, because I don't have a dial gauge, but I'm going to use this router bit to cut a track this way on the board and back again. That way I can see whether it's aligned with each other or not. I will do the same with the cut up and down. And when I look at the cuts, I will know where I need to angle the router, and I will put some shims behind wherever I want the router to tilt. And yes, I know this would have been much easier with some dial gauges, but unfortunately I don't have any, so I'm going to do it this way, and later I will get some dial gauges to do it properly. As we can see from these two passes, we can see a ridge in the middle here. This clearly indicates that the tool is tilted too much this way. So I need to place some shims behind the top of the router so I can tilt the tool more this way again. Let's try that. My plan is to use paper shims in the back of the top mount here to get the router more tilted this way. I will try to make them double at first. This was much better, but it's still not good enough, I think. There's a bit difference, but much better. I tried to adjust some more, but there still is a ridge here, so I have to do more shims. now I put some more shims in the top mount, and I also chiseled out some wood on the bottom mount to get the router down properly. And I must say this result is much better. These are 3 passes. I can almost not feel anything here. Here you can see my final trial. It's this area, and I can feel almost nothing, and that's good. I think I will go with this. That's how I changed the angle of the router to get a flush spoil board, just by shimming it with some paper and cardboard. Of course, later I have to use a gauge or something to get this properly done, but for now I am happy with this. So that's it for this part. Thank you for watching. Please subscribe and check out my Facebook, Instagram and website. And as always, see you next time. Goodbye, people. The first thing I do is to figure out how big my spoil board can be. It cannot be bigger than where the tool reaches on the flat of the CNC machine. So I'm going to manually drive my CNC machine to all the 4 corners of the maximum reach, and I'm going to measure how big my spoil board can be. I do it like this. I figure out where the center of my tool is. It's about here, and I draw a line 1 centimeter behind and on the side. That way this tool is going to go over the edge on the spoil board. I will do this in all 4 corners. subscribe for more and watch me on Instagram and Facebook. I also have a web page where you can get information and links to other stuff. Thanks for watching again. Goodbye. I mounted LEDs on the top here, and I have a micro switch on the lid which turns on some extra LEDs when I close the lid. As you can see here, when I close the lid, it really lights up your face. The CNC machine, when running normally, is a bit noisy. So I have for a long time wanted to build an enclosure for the machine. So that's what I'm going to do in this video. I have this old shelf material which I want to use. First, I'm going to remove this outer veneer layer with my jointer, and then I'm going to glue the pieces together so I can get some big boards to use in my enclosure. I have at least enough material to build the bottom, the two sides and the back. For the top and the front, I'm going to use some other materials that I have laying around. I'm going to remove the outer layer of veneer on these shelf materials and glue them together with normal wood glue. And I'm going to use this pocket hole jig to make some pocket holes and screw them together as extra security. Here you can see the drawings of my idea of the enclosure. To save as much space as possible, I want the lid to go up and lay on top of the enclosure when it's open. This way I also don't get an edge which I can hit my head in when I'm leaning in and attaching some stock and setting 0 point and stuff like that. So let's start the build. time is coming and I'm about to install it, where it's going to sit and install the CNC machine inside the enclosure. But before I do that, I really want to make some measurements of the sound. This is a decibel gauge and I want to make 3 measurements on each setup. I'm going to make one measurement 1 meter away from the CNC machine. The second measurement is going to be 3 meters from the CNC machine. And the last measurement is going to be inside my office or dust-free station. On each of the measurements I'm going to make 2 different measurements because I have a dust shoe on my CNC machine. I also have to have my dust extraction setup going. However, on my old setup I had this shop vac. The shop vac is very good, but it makes a lot of noise, high frequency noise. So when I'm measuring my old setup, I'm going to measure it with or without the shop vac. In the CNC enclosure, I have a new dust extraction. This machine is a 100mm or 4-inch pipe. And it also makes some noise, but it's lower frequency and it doesn't come out as loud. So when I'm measuring the new setup, I'm going to also measure with and without dust extraction, but this time it is with the new dust extraction setup. So let's make the measurements. First, I'm going to make base measurements on all the positions. This is the ambient noise in this room. 1 meter away, it's approximately 35-36 decibels. 3 meters away, it's about the same, 35-36 decibels, when there are not cars driving by. Inside my office space, it's as expected, about the same, 35-36 decibels. Let's make a measurement 1 meter away from the old shop vac. 83 decibels. 1 meter away from the new dust extractor. About 82-83 decibels. Okay, so we get about 78-79 decibels inside my office space with the old CNC with no enclosure and the old dust extraction enabled. I think you can hear me, but it's quite noisy inside there, so I have to use ear protection. 74 decibel. That is inside my office space with the dust collection activated. It's not that bad, and I can sit here without my air protection. But if I turn off the dust collector, now it's 62 decibels. I must say that is a lot more quiet than it was before. And I have no problem sitting here doing other stuff while the CNC machine is going. These were very nice results. Now let's go and check out my enclosure. I know this was a long video, but it took me a long time building this thing. About 5 days where I worked 5 to 8 hours every day. So it took a long time, but it's finished now. And I hooked up LED lights, and I have a micro switch on the lid. So when I close the lid, you can see some extra LEDs turning on. This makes for good work light down on top of the CNC. I hooked up the dust extraction to the new 4-inch pipe or 100 millimeters adapter here for the regular vacuum hose, which goes to the dust chute. The 4-inch or 100 millimeter hose goes to my new dust extraction. It's an Electra Besham. So I'm very happy with this build. I hope you enjoyed watching. I know the video was a bit long, but that's how it is. Please visit me on Instagram and Facebook. I also have a website you can visit where I have a lot more information. And as always, if you like this series or this video, please subscribe for more. And until next time, goodbye. It really lights up your face. You've seen me build the base for the CNC machine here in the CNC room or dust room or sanding room or what you want to call it. This table is built to the specs so I can fit my new CNC machine also. But for now I have my old DIY CNC machine standing here. This CNC machine has its own build series on my YouTube channel. I make a lot of mistakes while I build this one, and I learn from my mistakes and I fix the mistakes I do. I recommend you go back and check out some of those videos. In order for me to be able to build my new CNC machine, I have to get this old one up and running, because I'm going to use this machine to make parts for my new machine. This old machine works quite good. I've been very pleased with it. Even though it's made out of softwood and it's quite flimsy, it has served me very well, and I have learned very much from building this thing. Everything from the electronics with the stepper motors, everything with the linear bearings, the linear rails, the spindle itself, or in this case the MAKITA router. Also, I made this electronics box. As I said, it's been a very long time since I used this machine. I know there are some faulty circuits that I have to fix. Most of the faulty circuits are in these plugs. These are multi-connector plugs. So the plan now is to get the old CNC machine up and running. I have this computer monitor stand, room for 2 monitors on this one. This is some sort of temporary solution because when I build my new CNC machine, I want to make a new solution for the electronics box and the computer. And I was thinking about putting it somewhere around here, so that's the first thing to figure out. Yeah, as you can see, my electronics box has seen better days. After the initial workshop move, I had to hook up the CNC machine because I had to use it for a small job. In that process, I managed to short circuit 2 wires, and that resulted in these 2 TB6500s to lose its smoke and not work anymore. I used a lot of time to figure out what was wrong, but in the end these 2 were gone. So I switched them out with some new TB6600s. These are meant to be used on my new CNC machine. I also found a fault on one of the wires. That's why I put in this black wire here instead of the gray ones. So I had 2 problems that was mixed and combined into one problem. So I used a lot of time to figure it out. But anyhow, this is how the box looks today. I know it doesn't look good. I'm not going to use this small box for the new CNC machine. I have learned and figured out it's wise to have a box or electronics box that's bigger. This way it's much easier to research the faults if you get any faults in your system. When it's like this, when you're searching after a fault, you get chaos like this. For now, I'm going to use this box. I'm just going to hook up everything and check that every axis is working like it should. Okay, so now I have hooked up everything here. The computer is hooked up, the screen, the CNC machine is hooked up, but I have not turned it on yet. So let's do that. The first thing I do is turn on the electronics box. Okay, I can hear the power turns on and I can hear the stepper motors also power on. Let's check the CNC machine. Okay, so the first thing I do on the computer is to go into the UGS platform software. Let me see if you get this on the screen recording. I don't think so. I'll take it down on this screen. So here you have the UGS platform. Let's try to check out which COM port I'm connected at. Looks like it's COM port 9. I will try to connect. It says that it's connected. Now let's try the Y-axis. Oh yeah, it seems to work. Let's try the X-axis. Yeah, that also seems to work. Now let's try the Z-axis. Oh. There is no reaction on the Z-axis. I also have no holding power on the Z-axis stepper motor. All the other stepper motors have hold power. So something is wrong with this Z-axis. I'll just have to check on all my wiring and come back to you. Okay, I hope I found the fault here now. This is the stepper motor controller for the Z-axis. When I plugged it out, I saw that the wire was loose. So as you can see, the ground wire for the Z-axis stepper motor controller has gotten loose from the other one here. So I'm just going to hook this up and try again. When I hooked it up here, I heard the Z-axis stepper motor got the holding power it needs. Now when I try to rotate the Z-axis screw, it holds and I cannot move it. That means this stepper motor now has holding power. Finally got the old CNC machine up and running. It's on its own table here. I have wired up all the mains I need, 230 volts, going down to the machine here and down to the computer, which is on its own stand here. I've tested everything now and all the functions, all the axis works like they should do. I hope you enjoyed this video and enjoy watching my progress with my machines and CNC machines and stuff like that. I also do other stuff, so check out the videos you see on the sides here. And until next time. Wow, that was a long video. If you're still here, I have to say thank you very much for watching. I would appreciate a like on the like button. Thanks. Goodbye.